what kind of AI do you use? What kind of AI do you use? Gemini, what else? ChatGPT and Matthew. Same you, Matthew, okay? Cloud? Okay. So today I want to share with you what is the underlying logic of those kind of AI. All right? So basically, today we're gonna take a short detour, and I promise it connects directly to what we are about to study: logit, probit, and multinomial choice models, right? So let's look at this picture. On the left is something you already know, cloud, right? What is this? Linear regression. You are familiar with it right now. Fits a straight line through scattered points, okay? And then we minimize the error. That's what chapter 1 through chapter 4 about. But let's see the right side, which is the ACE curve, right? So we call it logistic or softmax. That's exactly what we study, what we will study in logit and probit. Instead of predicting a number directly, we predict probability. Okay, we predict probability. And the probability, what does it mean? So that we squeezed between 0 and 1, right? So here is the surprise. This same ACE curve is the mathematical core of ChatGPT or any other AI that you use. So here I'm gonna take ChatGPT as an example, right? They use this curve to function at every single step. So what is LLM? Do you know what is LLM?
Large language model.
Exactly, large language model. Actually, L means large, but actually it's not really the big size. It means many corpus inside, many literatures inside. Next one. So look at the contrast side by side. The left side, which is chapter 1 to 4, we predicted numbers on a continuous scale, which from education, right? The line just keeps going up and value possible. This was OLS, fits the straight line that best matches the dots, all right? But on the right, so after the exam, we're gonna learn predict probability. Look at this. On the x-axis is the probability, and y-axis we have 3 categories: grab, songtiao, or walk. And you should know that if we sum them up, the 3 numbers should add up to 100, right? So this is the new, and that's the whole idea behind multinomial choice models. Basically, they are the same toolbox, just different questions. Instead of predicting a value, we are predicting a probability distribution over categories. Okay, one point that I want to let you know. Right now, the goal of the AI company is they're gonna let AI become artificial general intelligence, which is AGI. What does it mean, AGI? Okay, so basically from AI to AGI. General means they want AI to think like us, like human being. All right, this is their goal. So I'm not sure about in your country, do you have your own AI platform? No, okay, because in China we have several of them, but to be honest, none of them is outperformed than ChatGPT and Claude. Right? So if ChatGPT and Claude they realized AGI, that means the AI platform in China they're gonna die for sure. Because the AGI is their ultimate goal right now for the AI company. So let's continue. You see here, this slide makes the connection explicit with a set of nested circles. Let's see, what is AI? Artificial intelligence, which is the broad goal. Inside this, machine learning. What is machine learning? Learning patterns from data, right? Inside that, we have deep learning, which is multi-layer neural networks. And inside that, we have large language model, okay, that like what we use now, ChatGPT, Claude, Gemini. So basically, they are model language sequences. So here's the point. Economists have been doing machine learning for decades. We just called it something else, right? Every time you run OLS, basically, we are predicting Y from X using weights beta. So we are doing supervised machine learning. What does it mean supervised? Because we have a goal, we labeled X, we labeled Y, and we want to know their relationship. This is supervised machine learning. Okay, so OLS is kind of supervised machine learning. So basically, you didn't just learn econometrics this semester. You learned the fundamental logic that sits at the center of the entire AI field. So let me give you an example. When you see this sentence, the capital of Thailand is, what is your answer? Why you know? Because you learned it. And the storage and the knowledge stored in your brain, that's why you know. But if you ask a computer, it doesn't know because computer only knows binary, 0, 1, 0, 1, right? So so if you enter this sentence in AI, the model predicts Bangkok, but where did the correct answer come from? Nobody sat down and manually label it, okay? The answer was already sitting in the training text. The model just learned to hide the last word and predict it from everything before it. So here we have supervised learning, okay? We learned OLS. So here, OLS, does data have an answer key? So here has an answer key with a human provided it. Like someone recording actual housing price. Okay, so this is supervised learning. Another one, unsupervised learning. So here, we don't have label, we don't have any label, and there's no answer key at all, just looking for structure of clusters in raw data. One example for unsupervised learning is that the advertisement you saw from Google, those are unsupervised learning. And the next one, which is self-supervised learning. So those are LLM models, right? They are self-supervised. What does it mean self-supervised? It does have an answer key, but it's generated automatically from the raw text. The true next word is the label, right? The true next word is the label. No human tagging required. So next time, you should be able to explain those difference to your maybe younger brother or your friends. This is the sentence to remember from today. LLM is not a magic. It's a trend probability machine. What does it mean? Look at the two icons. The engine with a check mark. Okay, this one, that's what an LLM actually is, which is a calculation engine. The brand crossed out with a database. That's what is not, okay? It doesn't think. The AI that you use right now, it doesn't think, okay? And it doesn't store a lookup table of facts. So what is actually computing? So basically, it calculates a conditional probability relationship between inputs and an outcome, just like econometrics. Okay, so here are the symbol line, just like a factory, right? So here is the symbol line, step by step. Let's see. Have you heard about token? Yes, you do. So you see, the first one is tokenize. What does it mean? So basically, we cut text into discrete IDs. Next one, we vectorize. So we turn ID into numbers, and then we do the attention. So we read the surrounding context. So the surrounding context is very important. So that's why you need to use a good prompt in order to use AI, okay? You need to have a good prompt. And next step, which is network math, okay? So they're gonna apply weights, the model's learned parameters. And then they evaluate, calculate the probability, all right? Calculate the likelihood of each possible next words. The last step, select and loop, all right? So they pick a word, feed it back into step one, and they repeat this circle. But today we'll zoom in on 3 of these stations to see exactly how text turns into probability. Okay, here, let's see, suppose this is the warehouse. And this slide explains why tokenize is necessary. So that's why you heard tokenize nowadays. Computer cannot do math directly on words. Like Bangkok isn't a number, right? So the first step of the assemble line converts each word into a vocabulary ID, just like a warehouse barcode, okay? Oversized package gets scanned and assigned ID. So let's see here. This package got ID, which is 1001. The number simply tells the system where this word lives in the vocabulary list, nothing more, right? So you see here, the number 1001 isn't bigger or better than ID 999. It carries no magnitude. It's literally just a shelf location in the warehouse. Okay, so think about a dummy variable for a categorical variable in regression. Region equal 3 doesn't mean region 3 is more than region 1, okay? It's just a label. There's no magnitude. There's no comparison. Next one. Attention mechanism, okay? Context matters. This is the key mechanism that makes modern LLMs work, which is attention. So let's take the word, which is bank, by itself. If I just tell you the bank, it's ambiguous. What do you mean? It's the financial institution or the river bank, all right? So that's why, look at the first sentence. If we use the surrounding text, okay? The bank raised interest rate. So in this case, here, banks looks around and pays attention to interest rate. So the neighbor gives away the financial context. If we sit by the riverbank, here, bank pays attention to river instead. That neighbor gives away the geographic context, okay? So that's why the surrounding context is very important. And do you wonder about right now? So basically, we are economists, right? But if you ask any question to AI, they can answer you correctly. Why did that happen? Yes, because there are other AI trainers feeding them a lot of literatures, a lot of knowledge, right? So basically, right now, if you ask one question, suppose in economics, in that AI, so the AI will call several experts, and then let them decide, discuss, and give you the most accurate answer. Just like the AI lets the experts have a meeting by themselves, but we can't see that. Okay, so you need to know the logic. Okay, here, just like the library analog. Okay, first one, query, right? What am I looking for? If you go to a library, what are you looking for? So the question is the token takes ask. And next one, what is the key? What can I be matched against? Which is the label other tokens present. And next one, values, which is V. It means that what do I actually deliver? The final context passed along once a match is made. All the three steps happens automatically, okay, through matrix multiplication. No human tells the model which words to connect. Here is the big review, okay, tying everything together. After all the attention layers finished reading context, the model produced raw scores called logits. Okay, so the raw scores, one number for every possible words in the vocabulary, basically 50,000 more of them. And these raw numbers can be anything, positive, negative, huge, or tiny. And then comes on the final step, converting those raw scores into probabilities using softmax, right? So basically, they squeeze in all 50,000 more numbers, so they are each between 0 and 1. And they all sum up to 100, okay? So in this example, 88%, 10%, or 2%. Basically, this output layer is a multinomial logit, all right? So let me give you one example. Before you came to Tsinghua University, suppose you ask AI, is CMU a good university in Thailand? What will the AI answer? Yes, CMU is the top 5 public university in Thailand, blah, 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 blah. And the AI will also tell you Thailand also have other good universities, Chulalongkorn, Mahidol. So you see, basically, the same the text, which has a higher probability. That's why it chooses you first. And then they also tells you we have other choice. So basically, the other university maybe have a very tiny possibility, but they still show you. Okay, so a good AI will show you all the possible outcomes and then let you select and think. Okay, so next one, the example that we just used. Okay, if you ask the capital of Thailand is, of course, Bangkok will get the highest probability. But what about banana? Think about banana. Banana's probability is not zero. Why? Maybe B. B? Maybe, right? Good question. But actually, in English or in Chinese, you know, how they decide is Bangkok a token or B a token? This is the secret of AI company. Nobody knows how they separate the token. Even in Chinese, we don't know. So that's why, you know, the biggest AI company right now, they try to train more language as possible. I think more than 200 right now, each language. So for each language, they separate the token. We don't know, but we can guess. Okay, so here is the thing. Why banana didn't get 0%? Because here, exponents. Do you remember the exponent function? It's always increasing. It's never gets zero. So that's why exponent is never exactly zero. So this mirrors why your econometrics probability models never predict exactly 0 or 100%. Basically, you will not hear an economist says, okay, tomorrow the interest will goes up 100%. Nobody gonna see that. For the safety reason, we see that the interest rate is more likely to go up. Okay, we use the probability. That's the art and also the logic of economics. And next one. Okay, so let's take a look at the probability model spectrum. So after your midterm exam, we're gonna learn binary logit. Okay, what does binary mean? 0, 1. So there are only two choices. So basically, if we only care about those two choices, we only can get one of them and we know the other. We just use one minus the other, right? So what it predicts, the probability y equal 1 given x equal what? Right? So think about the example, default versus no default. Fail or not fail, okay, binary. Next one. So the last chapter, we're gonna learn multinomial logit. That means we want to know the probability y equal k given x, right? So the example I showed you, walk or you take 胸条 or you took the graph, right? So the number of categories, maybe 3 to 5 categories, but for the AI that we use, okay, large language model, their output layer, it predicts the probability next token equal W given the context. Okay, given the context. Example, okay, Bangkok versus Chiang versus 50K others, all right? So in LLM, the number of categories is 50,000 more categories. So basically, the economics only changes the labels. The probability engine underneath is the exact same. Next one. Okay, on the left side, for OLS, we have closed form formula. What does it mean, closed form? So we have a specific formula to calculate. If I give you a number, you can calculate by your hand, right? Or you can use programming to do that. So this is closed formula for OLS. Just like we have the right target, okay, like this bull's eyes. But on the right, for logit or LLMs, there's no such shortcut exists, right? So later, we're going to use maximum likelihood estimation. So basically, we want to maximize the probability that y equal to 0. So here, including maximum likelihood estimation, they use iterative optimization, all right? So they solve through first order condition and second order condition you learned from microeconomics, and they adjusting beta step by step until the likelihood stopped improving. That's iterative optimization, okay? So there's no formula gives you the answer directly. You feel your own way down. Do you hike? Okay, if you hike, if you just like this hiker descending a foggy mountain, taking the steepest path down until you reach the bottom. So basically, we need to minimize the loss. Okay, minimize the loss step by step. This is exactly what happens when ChatGPT is trained. Billions of iterations, each one nudges the parameters a tiny bit close to better prediction. Okay, but basically they use the same first order condition, second order condition logic from logit, just repeat it at a massive scale. Let's see some terminology. So this one is worth remember. A direct translation table between AI vocabulary and our syllabus vocabulary. Okay, so when Silicon Valley says context or input tokens, it means explanatory variables, okay? The explanatory variable, the X that we feed to the model, all right? And then the next token, which means the dependent variable, which is Y. And then they use weights, but we use parameters, which is beta. They call it softmax, okay? We call it log link function or the other model, OLS, whatever. So basically, they train and they care about the loss minimization. But for us, take the maximum likelihood estimation. We want to maximize the likelihood, okay? And training corpus. What is corpus? Do you know what is corpus? Just like the literature review you are doing. Training corpus, okay? So if you want to write your own paper, of course, there are some paper that you want to follow, and you do the literature review, you upload it to AI, and you tell AI, these are my followed paper, okay? Please summarize their writing style. You need to train the AI, okay? Fit in their corpus. So of course, when you write an economic paper, you won't feed the AI with, I don't know, Chinese language, okay? Because, okay, so if you want to investigate something about consumer behavior, you may upload some paper about psychology, right? How people think, how people choose. So this is the training corpus. But in econometrics, we say sample and data set, all right? Okay. Corpus means a collection of written text. This one really matters. Just like, because every time when you use Claude or ChatGPT, you are one of the trainers to them. You feed in the information, right? So in Chinese AI, a lot of Chinese, they fit in the stupid words to the AI. I mean Chinese AI. So sometimes if we use Chinese AI, they're gonna reply us with that stupid words. So don't blame AI, okay? Because thousands of people, they are using it, fit in the stupid words.
What's the most popular Chinese name?
DeepSeek.
DeepSeek may be more academic, but for everyday life, they use Doubao TikTok. Doubao belongs to Chinese TikTok company, right? So there are a lot of, I would say, illiterate people. Okay, they use Doubao and they train Doubao with stupid words. And right now, Doubao is not intelligent as ChatGPT, of course. So next time, when your AI replied you some stupid words, think about what kind of text you trained for them, okay? Okay, so this is the last slide. An LLM is a trained probability machine. So right now, AI trainer, I don't know, in your country, do you have AI trainer? Okay, maybe I'm not sure in Thailand, but no more than 200 AI trainers right now. You may search. So LLM is a trained probability machine. From warehouse barcode to round table attention, and then to the final multinomial logit funnel, it all points to a single calculable chain, right? So you know the engine. After the midterm exam, we're gonna learn our first one, which is binary choice model. Okay, so this is the share about today. I want you to have a very simple logic about the logic of AI. It's not magic, okay? It's just about probability. And to be honest, I've never used any binary choice model, any qualitative model, because first of all, it's very difficult to get the data. And as a student, nobody gonna trust your data if you collect by yourself, basically. So before, I was not that interested in qualitative data, but right now, when I went to join the training, and I found that actually the logic is the same, just like supervised learning, unsupervised, and self-supervised. Okay, so I just want you to have the idea about this, and this is not about the exam. So today, basically, I finished my part. Do you have any question? Do you have any question about this one? Do you want to share about your own idea when you use the AI? Or do you have any other question about the midterm exam? No?
Can I also ask you the most sensitive percentage for one to account for the symposium? So do I need to submit documents?
You don't have to submit, but just show me the certificate, and I will count that as attendance. Okay. Any other question? Okay for the midterm exam. So maybe I suggest you the midterm exam, right? You finish the multiple choice first, right? 30 questions, and most of them you should be familiar with them because it's in Kabul. After you finish the multiple choice question, you do the, I don't know, maybe inference, t-test, f-test, okay? When your brain is still fresh. After that, you may do the calculation. Don't waste your time on the calculation part, okay? If it get wrong, you're gonna get trapped, okay? Or any feedbacks you want to tell me about my teaching, how the class organized, any improvements. Happy to know. If you want to tell me along, just come and talk to me. If not, so basically we finish the class and thanks for coming. So see you the end of this month and best wish for your exam.
Yeah.